Okay, so we talked about a central angle being equal to the arc that it intercepts. An inscribed angle, remember, is created when the vertex is on the circle, and the inscribed angle is half the intercepted arc. This is probably a formula that you should highlight. So in this situation, or in this diagram here, if I had this angle written as X and this angle written as Y, the inscribed angle X would be equal to half the measure of the arc Y. If inscribed angles of a circle intersect the same arc or subtended by the same chord or arc, then the angles are congruent. What I mean by this is if I have this inscribed angle, but if I have another inscribed angle, let's say over here, that intersects this same exact arc. So both of those inscribed angles intersect this arc right here. And that means both of those inscribed angles are equal or congruent. If an inscribed angle subtends a semicircle, then the angle is a right angle. What that means is if we have an inscribed angle like this one here, and it's spanning across a semicircle, which this one is, then that inscribed angle would be a right angle. It makes sense because a semicircle is 180 degrees and an inscribed angle is half the measure of the arc. So half of 180 degrees is 90 degrees. And then my last one, let me finish off this diagram. Okay, so this is an inscribed quadrilateral, and in an inscribed quadrilateral, opposite angles are supplementary. So for example, angle A and angle C are supplementary. So if I did X plus Y, that would equal 180. But also, angle B and angle D, which I labeled as A and B, are supplementary as well. Okay, so we're going to practice these 4 things about circles. So for the first one, we want to find the measure of arc ADC, which actually is an arc that was created by this angle here, which is an inscribed angle. That inscribed angle is half the measure of the arc. So if I take that inscribed angle and multiply by 2, I would get my arc, 270 degrees. Now I want to find the measure of angle DAE, which is this inscribed angle here, and that intercepts this arc here, DE. An inscribed angle is half the measure of the arc, so 76 divided by 2 gives me that angle is 38 degrees. Great. Next one, I want to find the measure of angle ABD. That's this angle here. It's an inscribed angle. It intercepts this arc. So if I do 86 divided by 2, that angle comes out to be 43 degrees. So the measure of angle ABD is equal to 43 degrees. Now we want to find the measure of arc BC, which is this one here. That is created by this inscribed angle. The inscribed angle is half the measure of the arc, so going backwards, I would take 60 and multiply by 2, so I get that my arc is 120 degrees. So the measure of arc BC is 120 degrees. All right, moving on to the next page to practice some more. For this next one, the measure of angle 1. That angle intersects this arc, which is labeled as arc 2. And also what intersects that arc is this central angle. And a central angle is equal to the arc length. So the arc length is 38 degrees. And that pink angle 1 is an inscribed angle, which is half the measure of the arc. So 38 divided by 2 would give me 19 degrees as angle 1. Now the next one, the measure of angle 1, that's this angle here, and it helps to highlight these angles to see what we're looking at here. This angle is created by this arc, so the angle is an inscribed angle. Half the measure of 114 gives you 57 degrees. Whereas angle 2 is a central angle that intersects that 114 degree arc, and a central angle is equal to the arc that it intersects. So angle 2 is 114 degrees. All right, the measure of angle 1, or arc 1, sorry. Arc 1 is created by this angle here. So going backwards, if I do 18 times 2, I get that this arc is 36 degrees. A full circle adds to 360, so 360 minus 100 minus 36 minus 134 leaves me with this arc being 90 degrees. And we needed that because angle 2 is an inscribed angle intersecting that 90 degree arc. So 90 divided by 2 gives me that this angle's 45 degrees. All right, the next one. So I'm finding the value of z. This angle that I'm given intersects a semicircle. So that means that this is a 90 degree angle. So I'm going to set the 8z minus 6 equal to 90 degrees. Adding 6 to both sides, I get 8z is equal to a 96. And a 96 divided by 8 gives me that z is equal to 12. My next one, I want to find EDF, the measure of angle EDF, which is this one. So this angle is an inscribed angle that intersects this arc. However, we do have another inscribed angle that intersects the same exact arc. So since both of these inscribed angles intersect the same arc, that means both these angles are congruent. So what I can do is I can set these angles equal to each other. Adding the 2x over, I get a 4x. Subtracting the 3 over, I get a 72. 72 divided by 4 gives me that x is 18. So to find the measure of angle EDF, I'm just going to put 18 in for x. So 2 times an 18 is a 36, plus a 3 is 39 degrees. Whoops. Okay, moving on. For this next one, we have an inscribed quadrilateral. So opposite angles are supplementary. So the 64 degree angle and angle 1 would be supplementary. So if I do 180 minus 64, I get angle 1. And for angle 2, that's supplementary with the 58 degree angle. So 180 minus 58 gives me 122. Great. For the next one, same thing. This is an inscribed quadrilateral. So for this one, the 118 and angle 2 are supplementary. So 180 minus 118 gives me 62 degrees. Now I don't have the opposite angle to angle 1. However, what I do have is that angle 1 is an inscribed angle. And for this one, it looks like it is intersecting an arc that is a semicircle. So since it's intersecting a semicircle, then that means that the inscribed angle is 90 degrees. Okay, so this next one, this is not an inscribed quadrilateral. So we cannot do the opposite angles or supplementary for this. What I do know is that this is a central angle that I'm highlighting that intersects this arc, and a central angle is equal to the arc it intercepts, so this is 102 degrees. And angle 1 is an inscribed angle intersecting that same 102 degree arc. So if I do 102 divided by 2, that gives me that angle 1's 51 degrees. Now, angle 2 is an inscribed angle that intersects this arc, which is the rest of my circle. So if I do 360 minus 102, that leaves me with that whole arc being a 258 degrees. And angle 2 is an inscribed angle, so doing 258 divided by 2 leaves me with angle 2, which is 129 degrees. All right, and last but not least, we have our last problem here. We want to find all the angle measures. This is an inscribed quadrilateral, so that means that opposite angles are supplementary. So if I add these two up, they should equal 180. So I have a 10x plus a 20 is equal to 180, or a 10x is equal to 160. Dividing by 10 on both sides, x comes out to be 16. So I want to find all the angles, so I'm going to put the 16 in for all the x's. So for angle M, a 4 times a 16 minus a 13 gives me that this angle is 51 degrees. For angle L, a 9 times a 16 divided by 2 gives me that that angle is 72 degrees. Angle K, a 33 plus 6 times 16 would give me that that angle is 129 degrees. And my last angle would be supplementary to the 72 degree angle since they're opposite angles. So 180 minus 72 leaves me with this angle being 108 degrees. All right, that brings us to the end of this video.